What if the greatest mistake in science isn't something we did, but something we assumed? For more than 20 years, textbooks have repeated the same number. The universe is 13.8 billion years old. Precise, confident, settled. Except it might not be any of those things. Because the more we look, the more the universe pushes back. There are stars that appear older than the universe itself. Clusters that shouldn't exist. Quasars that tick at the wrong speed. And measurements of cosmic time that flat out refuse to agree with each other. It's as if the universe is telling us we are using the wrong clock. So let's unwind the cosmic timeline. We'll look at the evidence scientists avoid, the clues hiding in plain sight, and the theories that suggest the universe might be far, far older than we ever imagined. If you ask someone how old the universe is, most people will tell you it's 13.8 billion years old. It sounds oddly specific, almost like we found a cosmic birth certificate floating in space. But the truth is a lot stranger, because that number isn't something we measured directly. It's something we calculated using a chain of assumptions that all have to behave perfectly for the math to hold. It starts with expansion. If the universe is getting bigger, you can rewind the tape and watch everything shrink until you reach a moment where the tape can't rewind anymore. That moment becomes the age. Simple in theory. To figure out the expansion rate, astronomers use a mix of tools. How galaxies move, how light stretches, how certain stars brighten or fade in predictable ways. These act like cosmic clocks, but the real anchor is in the cosmic microwave background, the faint afterglow from the early universe. By measuring tiny temperature ripples in that glow, scientists can model how fast space expanded billions of years ago. Run the equations forward, compare them to what we see today, and out pops 13.8 billion years. It's elegant, it's clever, and for a long time it seemed unshakable. But here is the part most people never hear. The age estimate depends entirely on the idea that the expansion rate has always behaved the way our models expect. If the universe sped up or slowed down in unexpected ways, even briefly, the age changes. If time itself stretches differently in different areas, the age changes. If our assumptions about the early physics are even slightly off, the age changes. In other words, 13.8 billion years is not a fixed number. It's a best guess built on a tower of cosmic dominoes, and some of those dominoes are starting to wobble. If the universe is really 13.8 billion years old, then every object inside it should fit within that timeline. Nothing older than the universe, nothing even close. You can't have a 100-year-old person inside a 40-year-old world. But in astronomy, that's exactly what we find in. One of the most famous examples is the Methuselah star, officially known as the HD 140283. When astronomers first measured its age, the results were so absurd that most people assumed someone had misread a decimal point. This star appeared to be 14.5 billion years old, older than the universe itself. Even after refinements, it still hovers close to the cosmic age limit. A star this old shouldn't exist, and yet, there it is. Then there are globular clusters. These are giant balls of ancient stars orbiting the Milky Way, and some of them appear to be pushing age limits too. Their stars look chemically mature, their populations stable and ancient, and their cooling rates suggest they formed far earlier than our timeline allows. White dwarf stars also give us a headache. Their temperature curves suggest some of them have been cooling for longer than the universe is supposed to have existed. Either they are breaking the rules, or the rules need updating. Now, none of these cases prove the universe is older. Astronomy is messy. Measurements are tricky, but when you start seeing multiple age problems from completely different methods, stellar evolution, cluster dynamics, cooling physics, you don't ignore it. You ask a bigger question. Maybe the problem is in the stars. Maybe the problem is the timeline we are forcing them to fit into. And if stars aren't the issue, something else is bending time in ways we still don't understand. If ancient stars were the first warning sign, quasars were the moment scientists really started paying attention. Quasars are the bright, hyperactive hearts of young galaxies, powered by supermassive black holes. Because they flicker in predictable patterns, astronomers can use them as cosmic clocks. The further away a quasar is, the more its light should be stretched by the expansion of space, and that stretching should make the flickering appear slower, a phenomenon called time dilation. Simple idea, clear prediction, easy test. Except the universe had other plans. When researchers studied quasars billions of light years away, they found something bizarre. Some quasars showed far less time dilation than models predicted. Others showed almost none at all. A few behaved like they were much closer and much younger than their redshift suggested. According to standard cosmology, that shouldn't happen. The deeper we look into the universe, the stronger time dilation should be. But quasars were acting like cosmic rebels, ignoring the rules completely. Scientists tried adjusting brightness, they tried recalibrating redshifts, they blamed black hole physics, they blamed dust, they blamed observation bias, but the mismatch didn't go away. It just became harder to ignore. Here is why this is such a big deal. Time dilation isn't optional. It's built into relativity. It's baked into expansion. If quasars don't slow down the way they should, then one of the two things must be true. Either their distances and therefore their ages are wrong, or our understanding of how cosmic time stretches across the universe is incomplete. Both possibilities point to a much older, or at least much stranger universe. And the more we investigate this, the more it becomes clear that cosmic time may not flow uniformly everywhere. Some regions may tick faster, others may tick slower. And if that's the case, our entire method of calculating the universe's age may be built on sand. And that brings us to a bigger question. What if the universe isn't expanding the way we think it is? If the universe's clocks are acting strange, the next place to look is the expansion itself. And this is where things get messy, because we treat the expansion of the universe like a simple, steady process. Space stretches, light stretches with it, end of story. But what if that story is incomplete? One idea that resurfaces every few years is the tired light hypothesis. It suggests that light doesn't get redshifted because the universe is expanding. It gets redshifted because photons lose energy as they travel through space. It doesn't replace the Big Bang, and honestly, the original version failed a lot of tests, but the modern variations of the idea explore whether light interacts with the cosmic medium in ways we haven't accounted for. Even if a tiny amount of energy drains over billions of years, distances and ages become easy to miscalculate. Another idea challenges a deeper assumption. What if the speed of light wasn't always constant? It sounds heretical, I know, but variable speed of light models have been proposed by legitimate physicists as a way to fix problems in early cosmology. If light traveled faster in the distant past, then our redshift estimates would artificially exaggerate distances, and that would make the universe seem younger than it is. There is also the possibility that time itself doesn't flow uniformly. Regions with strong gravity, different energy densities, or exotic fields might tick at slightly different speeds. That's not science fiction, it's relativity. And over billions of years, even tiny differences can warp our cosmic timeline. Then you have reinterpretations of redshift that don't rely entirely on expansion. Some theories suggest part of redshift may come from interactions with dark matter, quantum fields, or gravitational potentials. None of these ideas break physics, but they bend it in ways that could stretch the age of the universe far beyond 13.8 billion years. And here is the uncomfortable truth. If our assumptions about light, time, or expansion are even slightly off, then every distance, every age, every measurement we rely on could be off too. And that leads us to an even bigger idea. What if the universe wasn't born at all? Once you start questioning the age of the universe, the door opens to ideas that were once dismissed as fringe. And now they are getting a second look. These aren't wild guesses from the internet. They come from respected physicists who noticed the same cracks we are talking about. One of the most intriguing is conformal cyclic cosmology, proposed by Sir Roger Penrose. In this model, the universe doesn't have a true beginning or an end. Instead, it moves through infinite eons, each one ending in a cold, stretched-out cosmos that eventually morphs seamlessly into the next. No Big Bang as a moment, just a transition. If Penrose is right, the universe could be unimaginably old, and our estimate would describe only the most recent cycle. Another idea is the emergent universe model. Here, the universe didn't explode into existence, It slowly emerged from a timeless, static state. Imagine an ocean that develops a ripple, then a wave, then an entire storm. The universe grows out of something eternal. No singularity, no sudden beginning, just a slow transition from nothing happening to everything happening. There are also slow expansion cosmologies, where the universe grows far more gradually in its early phases than standard models assume. This gives galaxies, stars, and clusters far more time to form without requiring exotic physics or rewriting relativity. And perhaps the most intriguing, quasi-steady-state cosmology, a modern update of an older idea. It doesn't deny expansion, it just suggests that matter may be created gradually over time, allowing the universe to appear young in some ways but ancient in others. None of these models are proven, but the fact that serious physicists are revisiting them means one thing: the idea of a 13.8 billion year old universe isn't as solid as we once believed, and the true age might stretch far beyond our imagination. So what would it mean if the universe really is older? Well, the consequences would reach far beyond the number in a textbook. It would change everything: how we see the cosmos, how we understand time, and even how we think about our place in this story. For one thing, the formation of cosmic structures suddenly makes more sense. Galaxy clusters wouldn't need to rush their growth. Stars wouldn't have to ignite in record-breaking time. The earliest cosmic filaments wouldn't defy physics by appearing too organized too soon. And all the universe gives everything room to breathe. It also reshapes our idea about cosmic evolution. If cycles exist, as Penrose suggests, then we might exist inside just one chapter of an infinite saga. Civilizations, stars, entire universes could have risen and fallen long before ours began. And after our universe fades, another could emerge from its ashes, carrying faint fingerprints of everything that came before. Even the nature of time becomes slippery. If time flows differently in different regions, or if time itself can emerge from deeper physical rules, then our attempt to measure a cosmic age might be like trying to measure the age of a river while standing in one small stream. But here is the part that hits the hardest. If the universe is older than we think, then our entire cosmic story, the arc from nothing to everything, might be incomplete. Maybe the Big Bang wasn't the beginning. Maybe there were countless beginnings before it. Maybe beginnings aren't even the right way to think about the universe at all. What doesn't change is the wonder. We are still tiny creatures looking up at a vast, impossible sky trying to understand the story that began long before we existed. And that story might be far older, far deeper, and far stranger than we have ever imagined. When scientists announced the universe was 13.8 billion years old, it felt like a victory. A number, a timeline, a beginning. But the universe never promised that things would be simple. And as we've seen today, the deeper we look, the more that number starts to shake. Ancient stars that shouldn't exist, quasars that bend time in ways we can't explain. Models that stretch cosmic history far past the boundaries we set. Maybe the universe is older. Maybe time behaves differently than we think. Or maybe the truth is something we haven't imagined yet. What matters is that the questions are growing louder, and every new discovery pushes us closer to a universe that doesn't fit neatly in our hands. A universe that keeps expanding, not just in space, but in possibility. So if our cosmic clock is wrong, maybe that's because the universe is still teaching us how to read it. Thank you for watching. Keep looking up.